If nothing else, by now, hopefully at least you have a really good idea how this program runs. So we're going to look at it one more time. This time, though, we're going to focus on these trace tags. So anywhere you have in the comments, when you have the hashtag, the pep8 assembler actually uses that to identify variables and trace through them. So the idea is each one of these variables we have, so we got these three local variables, we want to be able to trace them and have the simulator keep track of them and show us where they are. So we put the hashtag in here, we say it's 2 bytes, and we tell it it's going to be a decimal. So if it was a character, we'd have a hashtag and 1 and C. You can also actually, instead of a D in here, you could actually put a H for hexadecimal, depending on how you want it to be formatted. So there are some options in there. There's a number of different options you can use, but most of the time you're probably going to be, if you're working with the numbers, you're going to be using the decimal. And then so that tells the program that yes, you want variables, but then as we know, when we do these equates, we're not actually allocating space. Space doesn't get allocated until we actually do the sub SP. So we need to also put hashtags down here to essentially link these variables that get allocated to those names up there and the offsets to them. So since we had exam1, exam2, and score, down here on the sub SP command, we put a hashtag exam1, hashtag exam2, and hashtag score. And then I'll show you how it all works in a second, but what you also want to have down here is at the end when you're deallocating space, you have the same variables but in reverse order. So the idea is they're going on the stack as you run down the list, and then they're coming off the stack as it's deallocated. And actually here, let me show you this. If you don't have these matched up somehow, like if I leave score off here, so as I'm telling it I want to put 2 decimals on the stack, but then when I'm done I'm only taking, or I'm trying to take 3 decimals off. If I go up here and try to assemble this, it's going to yell at me and give me an error. Says, warning, number of bytes allocated 6 does not equal number of bytes listed in the trace tag. So it knows there were 6 up here being allocated, but I didn't actually use them here, so it's telling me it doesn't match. Now, the program actually still runs. You can ignore all these blue errors and have everything work. But it is disconcerting. But that's the idea. They come in when you don't have the your hashtags aren't matching. So now I'm going to go ahead and I don't remember what state I left this in, so I'm going to start all over. I'm going to clear memory. I'm going to go ahead and build it, assemble it, and then I'm going to hit the little trace here, this debugs. So I hit the debug, and down here, this is where you actually see the trace tags in action. So as I run through, I'm going to step here, I'm going to step, and when I get down to this actual allocate here, this is where they really start to take effect. So I hit single step, and you can see I now have a marker for each one of those variables. So all 3 of my variables are now sitting on there. And if you think about this, these were up there. If we look at them, it's score 0, exam 2, 2, and exam 1, 4. Well, if I look over here at my stack pointer is FBC9, so that means my stack pointer is here at the very top of the stack. So my 0 offset is score. And if I go 2 bytes down, so because score is a decimal, so 2 bytes, I get down to here, which is exam, and there's my exam 2 with 2 offset bytes, and the same thing with the next one, 4. So that's essentially representing what I just put on the stack. And now if you step through this, so I do my single step and I enter in a number, I can see as soon as I enter it in, it goes, I can actually see it entered. Exam 1 got put into that location. So it's essentially showing you the same thing you could see by going out here to memory and going to the stack and looking at that location and seeing it's there. And honestly, you should understand how this is working out here with memory, but it's also a lot easier just to look here at the trace tag. So it really does help. So I keep on going single step. I put in my exam 2, I'll put another grade in here. I should use a different number, but anyway, put another number in there. So I got my 2 numbers, and it's again everything works as we've seen this program run before, whenever I do anything or store anything into those locations, I see them reflected down here in this stack picture. And everything stays there until I get down to that add SP. As soon as I do the add SP, everything goes away, so the deallocate happens. Anyway, so that's just a quickie demo of how the how those hashtags work. They trace tags, hashtags, they can really be useful to show you what's going on inside of PEP 8.